Good morning, seventh graders. Believe it or not, today is actually our last recorded class. I know it's only Tuesday, but tomorrow, remember, Wednesday is the day you're going to be doing your wonderful Wednesday video. I gave you a little preview about that last week. If you read the instructions with last week's Wednesday video, on Thursday, we usually have our live class on Thursday. Unfortunately, I'm not going to be able to do a live class with you. I have to have a dental procedure done on Thursday, right around the same time our class is meeting. And I'm probably not going to be in much condition to do a whole lot of talking that day. So we won't have our live class on Thursday. Instead, I'm actually giving you a review assignment that's sort of going to tie in this whole unit. It's one of those unit review assignments. Do your best on it. If you have questions, email me. I will try to get to you as much as possible. And then Friday for our last class, I'm just asking you to go on IXL for a little bit and just spend a little time doing your diagnostic. And then what I really encourage you to do is look at your diagnostic score and pull up the one from back in September when I asked you to save it. Think about the progress you've made. Remember, it's not a perfect measurement, but all of you have come quite a long way from where we were. So today's lesson is talking about volume. Volume is basically the three-dimensional space inside a figure. Surface area or area is flat. Area is like a carpet. Volume is like if you want to fill the space inside something. About 6-7 weeks ago, early on actually in the pandemic, my refrigerator died, or my wife's and my refrigerator died. It stopped working properly. So we needed to get a new one. And when you shop for a size of refrigerator, besides telling you how big it is in case you've got to cut out in your kitchen for a fit, it also tells you the volume of the refrigerator, how many cubic feet is inside it. Does it have like 24 cubic feet or 25 cubic feet or 26 cubic feet? Which is important to know because you need a refrigerator that will fit everything you need. If you've got a large family, you maybe need a larger one. If you've got a smaller family, say for example my wife and me, it's just the two of us and my 21-year-old son, maybe we don't need as much. Okay, so this is all by volume. So the formula for volume is fairly straightforward. It's V equals capital B times H. And the capital B refers to the area of the base. That's why it's capital and not lowercase. It refers to the area of the base, and H is the height. So if you've got a straightforward box like this, okay, you can picture the base. And in geometry, a three-dimensional object, a base is simply a side that's parallel to another side. We'll see that in a couple of regular shapes. Okay, but in this case, here's this base, which is 12 by 18. Okay, so the area of the base is 216 square inches. So volume equals the area of the base times the height. The area of the base is 216 square inches, and the height is 12 inches. And 216 times 12 is 2,592. And inches squared times inches is inches cubed. 2,592 cubic inches. That means if I had cubes that were all 1 inch on every side, I could fit 2,592 of them in that box. Okay. This question here is asking how many of these soup boxes would go in. So I could figure the area of the soup box here. Well, the base is 4 by 2, which is 8. The height is 6. 8 times 6 is 48 cubic inches. So I can just see now how many times 48 goes into that 2,592 to tell me how many of these soup boxes would actually fit in this box. Okay, and that's mainly how you find volume. I shouldn't say mainly, that is how you find volume. Okay, so we're going to do a couple of examples, and we're going to do a couple of irregular shapes. Okay, I'm going to start with one that has a trapezoid as its base. Okay, and here we go. And if you don't recall, or if you don't know the formula for the area of a trapezoid, you have the ability to look it up. Okay, gee, I'm not sure how to find the area of a trapezoid. You can go ahead and look it up. You have that technology with you. You can just type in Google area of a trapezoid. And it'll tell you the area of a trapezoid is a little bit drawn out formula, but it's 1/2 times the sum of the two bases times the height. So here's my trapezoid. The two bases are 3 and 6. So the area of the trapezoid is 1/2 the two bases. Remember, bases in geometry refers to sides that are parallel times the height. So it's 1/2. The two bases are 3 and 6, which is 9. The height is 2. Now, I could do a 1/2 times 9, which is 4.5, but I'm going to do a 1/2 times 2, which is 1, and 1 times 9 is 9. So the area of this base is 9 square feet. So you've got this nice big aquarium here. There's a surface area, or an area of the base, of 9 square feet. The height is 5 feet. So volume equals base times height, which is 9 square feet times 5 feet. The area of that tank, or the volume of that tank, is 45 cubic feet. Okay. Again, if you had 45 cubes, you'd have to cut them up a little bit because of the angles. But if you have 45 1-foot cubes, they would fit in that aquarium. Why you'd put 45 1-foot cubes in that aquarium, I don't know. But you could. Now, one of the things I do know is you can actually figure out how many gallons is this based on knowing how many gallons in a cubic foot. Again, that's something you could look up to find that transition number on IXL. I'm not on IXL, on Google. I'm saying too much IXL. Okay. I think just one more problem. I'm not sure if we're going to do much more. So now we have a different shape, a hexagonal prism. You've got this box that you want to put this basketball in. Okay. And let's see, it says, will the basketball fit inside the box as a regular hexagonal base so the lid fits on top? Okay. Well, I'd put the basketball in the box, see if it fits. I mean, I know it's wide enough. Okay. I don't know. Do I know the height? Okay. Okay. Let's see. Find the area of the hexagonal base. And then actually, yeah, so this is when we want to calculate height. We don't know the height. So that's what basically this is asking for, is find the height. Okay, so I had to look at the question a little bit first, but it's asking to figure out the height. And we want to make sure the height's at least 6 inches. It's in fact, it's got to be a little bit more than 6 inches. So first thing, we need the area of the base. Okay, now when you've got a hexagonal shape, okay, the book is going to be nice enough that it's going to give you a regular hexagon, meaning all the sides and angles are the same. So what you need to do is sort of think about that as broken up into 6 triangles. You can find the area of one triangle, okay, and then based on that, you can multiply that by 6 for the whole area. So here's a diagram where they've broken the top, or the base, into 6 triangles. Notice it's got I shouldn't say radius, but a distance from one side to the other 3.5 because it's 7 across. And each of the sides are 4. So here's one triangle. Because we've talked about surface area and you've looked it up, the area of a triangle is 1/2 base times height, which is 1/2 times 4 times 3.5. Well, 1/2 times 4 is 2, times 3.5 is 7. So the area of one triangle is 7 square inches. 1, 2, 3, 4, 5, 6. The area of all the triangles of the entire area of the base is 42 square inches. That equals the height. Okay? Now, I'm trying to find out where it has the volume. So it doesn't tell me the volume. Oh, it does tell me the volume. I'm sorry. It's right there in the diagram. So the volume of the box, I don't know why it tells you the volume and not the height. It seems a little ridiculous. But you know what? We wanted to buy a little kiddie pool for our granddaughter and grandson a couple days ago. And some tells you the dimensions of the pool in length and width and height. And some tell you just how many gallons it fits inside. So depending on which manufacturer you buy from, who knows? They may tell you some things. So the volume is 294. Okay. So now it's just a simple algebra equation. We can divide each side by 42. And notice you get a height of 7 inches. Okay. So the height is 7 inches. So that ball will fit inside. The ball only has a diameter of 6. So that ball will fit inside. I don't think I'm going to walk through this whole example. But if we just look at example 3 down at the bottom of the page, it talks a little bit about composite figures. Composite figures are figures made up of more than one shape. So this is sort of like a quote-unquote house, the type of house maybe you'd draw back in maybe when you're real little. Okay. Well, you'd find the volume of the two different shapes. So find the volume, first of all, of this cube. Okay. In which case, they've done that right there. Volume is base times height. Base is 18 by 18. Height is 18. Volume of the cube is 5,832. Okay. Then take the volume of that triangular prism. Remember, the base are the two sides that are parallel. The base is not the bottom here. The base is that triangle. The one of the sides is parallel. So base is 1/2 base times height, or 1/2 10 times 18, times a length of 18, or a width of 18. And the volume of that triangular section is 1,620. And you put them all together for the total volume. Okay, one here, this one here, you'd want to break up into 2 rectangular prisms. You could possibly do it by dividing it that way. Or if you didn't want to do that, you could possibly do this one by dividing it sort of this way. And have one rectangular prism here and one rectangular prism here. Again, if you have an irregular shape though, you just want to break it up into a couple of shapes. All right, so that's it for today. If you have any questions, please email me. Let me know the problem you're working on. I will try to get back to you as soon as I can.